Welcome to solverfy.
A general scenario where an object is floating in some liquid. Let's say the object's density is some rho, whereas where the fluid's density is rho naught, and the object's volume is v. Now, what fraction of the volume will be underwater? Now, the fraction of the volume underwater can be found out using the principle of buoyancy. The volume, this volume is also equal to the amount of water displaced, and the amount of water displaced is equal to the weight of this object. So let's say the volume of this submerged part is V2. Then V2 times the amount of water displaced also has the volume V2. So the weight of the displaced water is V2 times rho naught, which is the density of the fluid. So this is the mass of the displaced fluid. Now let's multiply it with G because we need weight of the displaced fluid. Now this weight of the displaced fluid is equal to the weight of the object, which is its total volume times its density times G. So now using this equation, we simply cancel the G out and we have the volume submerged divided by total volume is equal to rho by rho naught. That is, the fraction of its volume that is submerged will be equal to the ratio of the density of the object to the density of the fluid. So obviously we have three options: water, salt water, and mercury. So obviously, if the density of the fluid is larger, the fraction will be smaller. Now water has the least density among these two, among these, followed by salt water, followed by mercury, which is really heavy, very dense, which means the fraction of the object under the surface will be the greatest for water, followed by the salt water, followed by mercury.